Alrighty, so in this video we're going to dive even deeper into our study of data structures. And we're going to do that at first by revisiting a problem that we talked about in the last video, or at least a similar problem. So as you'll recall, we created a two-dimensional array of grocery lists. So it was a list of lists, an array of arrays, if you will. So what I'm going to do is make another grocery list array. We're just going to use the one this time. So I guess whatever side hustle you had where you were going and getting all of those items, you're doing all the shopping for your apartment complex, it didn't pan out. They decided they were better off just going to the store on their own. So you're just getting stuff for yourself now. And you've got your eggs and your milk and your whatever. So we'll just put those in there for now. So you got your list, and we can print that out. All right, let's see that that works. And there we go, there's our items. Let's go ahead and add a couple more things. Let's say you needed some batteries as well. And some cake mix. And the batteries are not going to go in the cake. I know this looks like you're getting all the ingredients for a cake, but that's not what the batteries are for. Maybe they're for like your mixer or something. Okay. So you've got your list. We'll run it one more time so we can see that it works. And there we go. But you realize while you're on your way to the store, I forgot to add something to my list. I wanted to also get flour. Well, once you've made this array, right, it's like a box. You can't change the size of the box. You can't stretch the box to make it bigger. Our box only has 4 spaces in it, and we filled up all 4 of them. So I have nowhere to add flour. I can't put it on my list. So that's not great. I'm kind of stuck. So okay, let's think ahead. Let's be smart and let's plan for that. I'll put a null in there. That way, if I ever forget an item, I can just add it later. So what we'll do is, I notice I'm missing it somewhere else in my program. So we'll just put do some stuff here. And then down here, later. So imagine there's some more stuff going on in the program. We're doing something with the list, maybe. And then down here, I'm like, oh, wait a second. I forgot I also need flour. So I add the one at the end. That's position 0, 1, 2, 3, 4. Oops. Flour. Okay. Cool. So I added it to my list. But then I realize, wait, I also need sugar. I don't have any sugar for my cake. Well, now I'm stuck again. I didn't plan for this. So at the beginning, before I started anything, maybe I needed to have another null here. I needed another empty space, some more padding, just in case I needed another item. Okay. Okay, so that worked. And notice the key here is, I didn't know that I needed flour and sugar when I made the thing. I only realized that I needed them after the fact. But at the beginning, I was smart enough to include spaces for me to put them in. So the question is, how many spaces do I need? Because what if I'm like, oh, hold on a second, I also need cinnamon, and I need tomato sauce, and I need pepperonis, and I need cheese. You see, I could keep adding stuff to my list, and my list doesn't have space for it. I have to keep adding these nulls. So what do you do? Well, what you could do, this is one solution, is don't even make it this way. Just create it like this. New string array. Oops. And then add a bunch of spaces. I don't know. 100? Do you think I'll ever have a list that's bigger than 100? So I'll have 100 spaces that I can fill up, which in most cases is probably enough. But even then, that might not be enough. If I want 101 items, uh-oh. So, 1,000? Then we'll want 1,001 items. So you see the problem here? No matter how big I make this, there's always a maximum. And I could reach it. And that would be a problem. You're probably not going to need a list of more than 100 items. So, okay, we could say fair. For practicality's sake, let's just do it that way. And then we'll just add these like this. Alright. Whoops. So that's definitely doable. We've made some progress. We sort of solved our problem. And now we don't have those nulls anymore, those ugly nulls. At least not here. But if we were to print this out, let's go ahead and let's run it. Let's run it and print it. Yuck. That's yucky. Look at that. Ugh. All those nulls. So you could put a filter in here and say, if item does not equal null, then print it. Okay, so the list looks better now. Or the array looks better now. But we really didn't fix it. We just sort of covered it up. It's like having your house is a mess and you got guests coming over. So you just run and you throw all the junk in the closet and you sweep all the dust under the rugs. You didn't really clean anything, you just hid it. So all those nulls still exist, and we looped through every single one of them. So it slowed our program down, for one. It looped through 100 things, even though we only actually had like 6. And it's also taken up all that memory. It's taken up 100 memory spaces. The box has 100 slots in it, but we're only using 6 of them. So that's not great. That's not something we want to do. So is there actually a way that we can get around this? And before we get to that, actually, there's even another problem. Let's say you're at the store, right? And you've got a list that's got 100 items on it, or got 99 items, or whatever. And you want to keep track of what you've got. So how are you going to do that with this? Are you going to say, like, grocery list at 2, let's say I got my batteries first, set that back equal to null, and then we don't need the batteries anymore? I guess that's how you'd have to do it here, just to get rid of it. But how are you going to remember that the batteries are at position 2? So you're going to end up with all these nulls, a lot of wasted memory. You're going to need a super big box just in case someone wants to make a big list. And even then, you're not going to be able to hold everything. You could still spill over and then you're stuck. And then you've got all these ugly nulls. So is there a way in Java that we can solve this problem where we can get a list that's easy to add things to and take things away from? And the answer is yes, and there's actually very little that we're going to have to do here to make it happen. So we're going to use something called an array list. So there is a difference between a list and an array. It's just easy to think about an array as being a list, but this list is made of an array. So it's an array list. And we'll call it grocery list, and we'll rename this thing grocery array. Okay, and just like before, see how we had to tell it what type of array we wanted? We have to tell it what our array list is going to hold. The way you do that is with these little angle brackets. So it's going to hold strings. So we want an array list that holds strings. So I'm going to go and get rid of that actually. And then there we go. Let's comment this out. Look at this. Little bits at a time. Okay, so let's compile it, and you'll see we're going to get an error. So it cannot be resolved to a type. So what exactly does that mean? Well, if you see an error like this, it means that it doesn't know what this is. And it turns out that the array list is actually not included in the default Java stuff. So you're going to have to import it the same way that we import the scanner. So java.util, and then instead of scanner, we're going to type ArrayList. And that will clear up that error. So you see it compiled. And let's print the grocery list. So look at that. We got these little brackets. So this is actually showing us the actual list. If you remember from the previous video, or maybe the one before that even, when we printed out the array, we got this sort of ugly pointer reference thing, and it didn't really tell us what was in there. It was just some sort of machine gibberish that was really hard for us to read. Well, it doesn't look like that's what the array is going to do. So let's actually try to add something to this array, and then we'll print it out again. So the one drawback to using an array list, as opposed to using just a strict array, is you can't create it with a bunch of stuff already in it, not in a sort of easy, non-trivial way. Whereas with the array, you could. You could use those curly braces and just plop a bunch of stuff in there immediately. With the array list, you have to make the list and then add stuff to it. But that's easy enough. It's got a method on it, because this is actually an object. It's got a method on it called add. So we can add eggs to it. We compile this, run it, and look at that. Eggs. They're in the list. Okay. So grocery list dot add milk. Grocery list dot add batteries. Grocery list dot add cake mix. There we go. So you can just print this one out in one line, and it'll print out this nice little list down here for you in the console. So we can delete these. And then if you wanted to, you can also iterate through this. See, nice. And so that doesn't want to uncomment. There we go. Okay, so you can also iterate through it like this. And we don't need this if statement anymore. You can also use the enhanced for loop with an array list. So you can print them out one at a time. And you could use this to do something to every item in the list if you needed to. So eggs, milk, batteries, cake. Eggs, milk, batteries, cake. And let's say you wanted to add flour and sugar to it. Oops, we'll leave that there for now. So you want to add the flour and the sugar. No problem. Same as before. There we go. Compile it. Run it. So you see, batteries, cake mix. The flour and sugar isn't in the list yet. But then we add it, and when we iterate, there it is, the flour and the sugar. So there was no size constraint, so we could keep adding these things forever. To prove that, let's add a bunch of sugar. For int I, starting at 0, while I is less than 100, I++. And what we're going to do is we're going to add sugar to the list. So notice, this was the list before, and then we added flour and 100 things of sugar. We really need it. And we didn't hit any sort of size constraint. We can keep adding. So let's do 1,000. So I didn't have to specify all those nulls. Okay, let's okay, it stopped. So I'm going to get rid of this now. That was just to prove to you that you had as much space as you needed. You can keep adding to this thing indefinitely as long as the computer has memory and Java has memory for it. Okay, so that solves one of the problems. We can now add to the list. But the other question that I raised right before we dove into the array list was, what about taking things out? Can you remove something from this list easily? And yes you can. So let's see, we wanted to remove the batteries, I believe. The batteries are at position 2. So you do dot remove 2. Now that's easier than remembering to set something equal to null, right? Just remove. So we're going to run it. You see eggs, milk, batteries, cake. Eggs, milk, cake, flour, mixed sugar. So we added flour, we added sugar, and we took the batteries out. So no problem. Okay. What if, here's something else you could do, and you could have done this with a array of strings as well, but it would have been difficult. It would have been the same sort of thing as removing, and we'll see why this scheme is better in a second. But what if I decided I didn't want milk, I actually wanted, I don't know, like half and half. So I could do this, dot set, and milk is at position 1, and we're going to set that equal to half and half. Compile, run, there we go. So I didn't even have to remove the milk and then add half and half. I was able to do that all in one step. I took the milk out and I put the half and half in. So you can add, you could remove, and you can reset. So this is still a little bit If you're like me, this probably has you skeptical. You're like, well, yeah, I could remove the milk and replace it with the half and half, but I had to know where the milk was in the list. And that can be a little tricky, especially if you're changing the way that the list looks. So let's say we removed the eggs. Okay, so we removed the eggs, and then we actually replaced the, looks like the batteries with half and half. Eggs, milk. Yeah. So that's no good. We didn't want to replace the batteries. We wanted to replace the milk with half and half. So, what might be a way that we could do that? Well, if you remember from the strings unit, there was a method called index of. And we can use that here. The index of the milk And that's going to return to us where the milk is located in the list. So let's go ahead and print that. And we'll comment this out for the time being. So find the milk. And the milk is at position 1. Looks good to me. And if we were to remove the eggs again, well, now the milk is at position 0, because there are no more eggs in this list. What if we remove the milk? Well, the milk is at -1, so it's telling us there is no milk in this list. So if you wanted to check if something was in a list, this would be a pretty quick way of doing it. Just check if this thing equals -1. So instead of printing this, what if we use I? So we get wherever the milk is, and then we replace it with half and half. Oops. Oops, I removed the milk. So if you're going to do that, make sure you check that this isn't -1. If there is no milk in the list, you can't do that. Okay, there we go. So the milk has been replaced with a half and half. Alright, but what happens if there's 2 things of milk in there? So there was a milk here, and there's one down here. Only the first one gets replaced with half and half. So if you remember, it's the exact same thing as it was with the strings. Index of returns the first index. So the first time that it sees milk, it's going to return that, which in this case was position 0, because eggs had been removed. And we could do the same thing up here. In fact, we should. We'll call this one J, because we already used I. And there we go. So you could use these methods to create a class that managed an array list that kept track of the items in a grocery list. So as you were shopping, you could like hit a little check button and it would say, okay, I got the milk, and then the milk would be taken off the list. Or you could replace an item. What if you want to insert an item and you don't want to put it at the end? What if these things are ranked by how important they are, or something like that? What if this is a sorted list, if you will? What if I figure out, hold on a second, I desperately need sprinkles. My entire dessert, my entire birthday party, whatever, it's going to be ruined if I don't get sprinkles. So I don't want to forget, I got to put them at the top of the list. What do you do? How do you do that? So let's go right before we print out all the items, and let's add sprinkles to the list. So grocery list dot add sprinkles. So let's just see what that does. And there we go, we got sprinkles on the list. But they're at the bottom. And if this list gets too much longer, I might forget some stuff. Or I might not have time to get to everything, because the party's coming up soon. But the sprinkles are super important, so I want them at the top of the list. Luckily, Java has got you covered here too. You can specify where you want to add it. So let's put it at the beginning. Let's put it at 0. And then what it does is it pushes everything else down. So we didn't get rid of anything. We added sprinkles, and then whatever was at this position got pushed down, and so did everything else. So if we put it here at position 1, you'll find that it's between the half and half and the batteries. Oops. So half and half, sprinkles, batteries. So you can choose where you want to put it if you put a number in front of it with this add method. So the takeaways here are the array list, unlike the array, is resizable. You can add things and remove things from it and it's going to be happy. It's going to let you do that. You can do those operations using the add, remove, and index of methods, and the set method as well. Now there are a couple things you got to take into consideration when you're using the array list. For example, you can't actually populate it with these items at the beginning. You have to just make a new one. And another thing, let's say you wanted to print how many items are in there. So this is actually another pro to using the array list. If you were using an array and you printed out the length, that would tell you how big the entire box was, not how many items were actually in there, because it doesn't know that null doesn't count as an item. But with the array list, what you can do is system.out.println grocery list dot size. And what that will do, and notice there are parentheses here, what this will do is actually print out the true length of your array, or your array list. So we'll put it here, and we'll put it before we print the list the first time. So it starts out at length 4, 1, 2, 3, 4, and then it's at length 7 by the time we get here. So that tells you how many items are actually in the list. So if you wanted to do this without doing the enhanced for loop, you would have to do for int I, let's call it k because we already used I, or we use x, equals 0, while x is less than grocery list dot size x plus plus system.out.println grocery list dot get. I don't think we used get before, did we? So instead of using the square brackets that you would use on the array to get something at position, you can use get, and you're going to get what's at position x. And let's do this just to give us a little bit of space. And we should see it printed twice. Beautiful. So obviously for an example like this, we're just printing the items. This is probably the more elegant, clean way to go. But you could also do it this way if you so chose. If you wanted to number them, for example. Oops, let's compile it. And we'll run it. And there we go. So if you wanted them numbered or something, then this might be the loop that you'd want to use. Okay. So let's see. One more thing I think we should look at. Oh, two more things. So let's actually talk about how you could clean this up a little bit. So I know at the beginning that I want these 4 things. And it might be 10 things, it could be 20 things, but there's some amount of things that I know I want to include at the beginning. And I have to add them one by one by one. So you can imagine this would get pretty long and pretty ugly. So let's get rid of this. And for the sake of argument, let's just assume, well, let's just leave that where it is so that we can show that this doesn't break anything. We got these 4 things. What we can do is actually create an array like we were doing before. We call it items. And we'll make it the same way that we're used to, putting the items in there. Okay, so we're already down to 1 line where we originally had 4. Then you can say for string item in items grocery list dot add item. So that's still 4 lines long, but it looks a lot nicer. And it's going to stay 4 lines long, even if I add something here like soda. So let's compile it and run it. And there we go. See, it still worked. We still got rid of the eggs, and we still replaced the milk, despite the fact that I added soda to the list. And you could add something else here. Let's say we also need cups. We need something for the soda. Something to hold it. Cups. And you see we didn't have to add any lines of code to do that. And I think if you were feeling fancy, you could do this as well. Okay, maybe not. Okay, yep. It's probably for the best that you can't do that because the code was starting to get ugly. So, yes. These 4 lines here will populate this array list for you. Alright, as promised, one more thing, and then I think you'll have a pretty solid understanding of how these array lists work and their benefits over the array. Okay, but before we get to that, actually, 2 more things. We'll save that for another video. Okay, so when you're iterating through one of these bad boys, you got to be careful. So we just showed that you could add to an array list in a loop. So what if we did something like for item and grocery list, instead of printing, or in addition to printing, we want to do grocery list dot add item. So every time we go through an item in the list, so we're going to go through and we're going to see something that's going to say milk. Then we're going to add milk to the end of the list. Then we're going to print milk. Then we're going to go through. We're going to see batteries or whatever. We're going to add batteries to the end of the list. Then we're going to go through again. Do you see what might be the problem here? So you see, it's actually going to throw an error because we were going to get ourselves into some trouble. Some serious trouble. And let me verify that that is indeed what caused the error. Yes. So this was going to get us in some serious trouble because this is going to be infinite. If we're always adding to the list as we're going through the list, we'll never reach the end of the list because we can't. For every step we take, we make the list one bigger. So boop, 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 boop. The goalpost keeps moving. We're never going to reach it. So it's good that Java stopped us. But there's another thing that you can do. You could remove instead of add. And that's going to have the opposite effect. The list is going to be shrinking on you while you're trying to run across it. And we get the same thing. You're not allowed to modify while you're iterating through it. So that's good. Java's stopping us from being dumb. But what happens if we don't use this modified or this enhanced for loop? What if we use just the normal old one with the indices? Now we might be able to get ourselves in some trouble. So let's try the add first. And we can't add the item. We have to add the grocery list and whatever's at X. Oops. So right now, Java doesn't know that we're iterating over the array list, the grocery list. It doesn't know that. It just knows that we got some variable called X that we're using to go through, and we're stopping as soon as we reach the size of the list. So to us, these two things are equivalent, but to Java, there is a slight difference. So let's compile it. Let's run it. Look at that. You see, we didn't get an error this time. Because Java can't help us here. We were dumb, and we were dumb of our own accord. So no matter how far we go, we're going to keep adding 1 to the end. So it just keeps going forever. We're never, ever going to reach it. So let's see if I can actually, can I stop this? Okay, cool, I killed it. So that's no good. So you don't want to do that. Don't ever do that. Maybe if you're smart, there might be a situation you want to add. I really doubt it. I would stay away from this. I would not modify the list while I'm iterating through it. And let's try remove. And remember, this one was identical to this one when we first started. So half and half, sprinkles, batteries, cake mix, soda, cups, flour, sugar. Sprinkles, cake mix, cups, sugar. So we only got every other one. That's because it was removing as it went. So we don't want to do that either. Whenever you're modifying the thing that you're currently iterating over, you are asking for trouble. You're going to want to make a copy of it and then maybe iterate over that copy while you edit the original. Because if you think about it, it's worth looking at. We had something like this. Right? And let's say x started at 0. So we'll put numbers in here. 1, 2, 3, 4, 5. And we want to iterate through and remove them as we go. So x starts at 0. We print out the 1. So that is what we're doing first, right? Oh, we remove first. So we're going to remove what's at 0, which pushes everything forwards. This is now 0. That becomes 1. That becomes 2. So 1, 2, 3. So then we printed this one. So that's why we got that second one. And then this becomes 1. So we go through again. We look at 1. We remove it. Then we slide everything down. So this becomes 1. That becomes 2. And then we go to the next one. We go to 2. And you see, this one was 2, but now it's 1. And we remove it. And that's what's going on. And we printed that one. So we're actually missing things because the list is actually shifting underneath of us. As we're trying to walk along it, it is moving because of what we're doing. And that's no good. So, do not save. So when you are iterating through a list of any sort, or really any data structure at all, please never edit or modify what it is that you're currently iterating over. You could either get yourself in an infinite loop like we saw with the add, or you could end up inadvertently missing things with the remove. So you got to be careful. And with that warning, I think we'll end this video. And if you have any questions, let me know. If you weren't able to get any of this stuff working, or some problems arose, let me know. And I'll see you in the next video.